Welcome back to physics class. Children, in today's session, we will solve few more problems based upon the next topic, that is related to electric current. Okay, children, when I say electric current, what formulas should come in our minds? Yes, good. I is equals to Q divided by T. So based upon this, today we will solve few more problems, children. The question comes, if a potential difference of 10 volts causes a current of 2 amperes, means the voltage 10 volt is making a current 2 amperes flow for 1 minute, means duration they have given it as a 1 minute, then how much energy is transferred here? So what are the given things, children? That is V is equals to 10 volts, current I is equals to 2 amperes, then time is equals to 1 minute. Children, here you have to concentrate because the duration time it is given in terms of minutes. So convert it into seconds. 1 minute is having a 60 seconds. So T is nothing but a 60 seconds. Now, what we have to calculate? Energy. Nothing but a work done is how much, or energy spent in making this flow of a charge is how much we need to calculate. So, what formula shall we use, children? That is, we know that I is equals to Q divided by T. Isn't it, children? This is what? One formula. So, we know we already have a I value and T value we have. First, we need to calculate Q here. So, we can rewrite the formula. Q is equals to I into T. So, what is I value? 2 amperes into T value 60 seconds. So, this will become now 120 coulombs is the charge. Isn't it, children? Then, for this much amount of a charge, how much energy is spending? That is, how much work is carrying out here we need to calculate. So, what formula we need to use now? That is, V is there, Q is there. We want what? W. So, from formula, V is equals to work done divided by Q. So, substitute now. That is, we want W, no? We can rewrite this. W is nothing but a V into Q. W as it is. What is the V value? 10 volts into Q is 120 C. So, W is equals to 1200 joules is the energy spent. Got it, children? So, in this problem, what we have solved, how we have solved? First, the given data we have collected, it has given in a minute, so we have converted into seconds. After that, we want to know what? Charge value, because with the charge only we can calculate the work done. So, I is equals to Q divided by T. Based upon this formula, we can get a Q value. Now, after obtaining this Q value, we have to substitute in the potential difference formula. That is, V is equals to W divided by Q. Then we will get W as a work done or energy is transferred. Got it, children? Okay. Now we will move to the next question. See, what is the question? This. A radio set, it is drawing a current 0.36 ampere, means it is using current 0.36 amperes for how much duration, children? For 15 minutes. And calculate the amount of electric charge that flows through the circuit. Here they have asked us to calculate the electric charge, nothing but a coulomb, isn't it? That is Q. In terms of a coulombs, we want to calculate. So, what are the given things? Current I is equals to 0.36 amperes. Time T is equals to 15 minutes. So, if we converted into seconds, then it will become 900 seconds. So what is the t value? 900 seconds, isn't it? Then q is how much? Then using formula, isn't it, children? Using formula, I is equals to q divided by t. This can be rewritten means q is nothing but a I into t. Now substitute the values. So q is equals to, what is I value, children? 0.36 amperes. What is t? That is 15 minutes, nothing but a 900 seconds. 900 seconds. So if we multiply this, means this can be written as a 36 divided by 100 into 900. These two get cancels, isn't it, children? Now what has left? Then 324 coulomb is the electric charge, isn't it, children? This is what this much amount of that is charge has spent here. Got it, children? How to solve? First, what we did, the time has converted into seconds. After that, directly with the help of the formula, we have calculated charge. That is q value we have find it. Now we will see one more question, that is how many milliamperes are there in 1 ampere. It is clearly saying that 1 ampere constitutes how many milliamperes. We already know that 1 that is a milliampere is equals to 10 to the power of minus 3 ampere. 10 to the power of minus 3 ampere, nothing but a 1 milliampere. Now, how many microamperes are there in 1 ampere? That is 1 microampere is equals to 10 to the power of minus 6 amperes. Okay, now the next question, why should the resistance of an ammeter should be very small? See, children, this is a very important, isn't it? Why the device ammeter should have a very small resistance? Because the entire current, that is the total current, has to pass through this device, isn't it, children? Because of that purpose, its resistance should be low, means very small. Got it? Because the total current has to pass through the device, isn't it, children? Because we are measuring the current, because of that the entire current should be passed through this, isn't it? So it should have a low resistance. So what is the answer? The total current has to pass through that device and hence it should have a very small resistance. Whereas a voltmeter should have a very large resistance because it passes, that is it allows a negligible amount of a current through that, isn't it, children? Because it takes a negligible amount of current, means a very small amount of a current is flowing, so its resistance should be what? More, means high. Always ammeter should have a low resistance because it has to measure the entire current which is flowing in the circuit, whereas the voltmeter it allows only a small amount of current. Because of that reason its resistance should be high. And one more very important we need to understand here, ammeter should be always connected in a series, whereas voltmeter should be in a parallel, children. This question is based upon logical thinking, children. One circuit diagram they have given, and based upon that diagram here they have asked a few questions, isn't it? So let me read the question. A student made an electric circuit shown here to measure the current through the two lamps. This is what electric circuit made by the students, isn't it? And here two lamps they have used. And the first question is that all the lamps are in series or parallel. We want to know that. Then second is the student has made a mistake in the circuit. What is that mistake? Then third question is of using proper circuit symbols, draw a circuit diagram. The first question is clearly saying that how the two lamps should be connected here. That is what type of a connection here they made, means students made. When we look at the circuit diagram, we can say that because side by side are there, so we can say the two lamps are in series. So what is the answer of the first question, children? A is two lamps are in series, isn't it, children? Because both are side by side. Side by side means series, isn't it? The next, we'll move to second question. They had made a mistake. What is that mistake? See, children, here the ammeter has downwards, means this is a mistake here, because always ammeter should be in a series. Got it, children? The what ammeter is in parallel. The students made ammeter in parallel. This is what mistake, because it should be in a series, isn't it, children? Made ammeter in parallel. Then using proper circuit symbols, we should draw a circuit diagram. Do you remember, children, what the symbols we have to use for a battery and a lamp? That is nothing but a bulb and an ammeter. So shall we draw now? The correct circuit symbol is first 1, 2, 3, means 3 cells. Instead of using 3 cells, we can draw a battery there, isn't it? What is the symbol of a battery? One long line and one small line, isn't it? The long line indicates positive terminal, the small line indicates negative terminal. Got it, children? Okay, now how they are connected? To first an ammeter, isn't it? Then to electric bulbs. Got it, children? And the current starts flowing in this direction. Got it? This is what the correct method of a drawing circuit diagram here. Understand, children? It's a very easy. Here we have used ammeter's symbol here, isn't it, children? That is plus and negative. Got it, children?